Hello, childrens. So I wanted to give you a little help on your evidence of evolution packet. So the first questions are about the evolution of modern horse. So if you look at this over time, you need to come up with some differences in the skull and the anatomy and the leg anatomy, so that shouldn't be too hard. Here you're just going to guess the embryos. That's just kind of for fun to see what happens. And then when you get here, what physical similarities exist between each of the embryos? What I'm looking for there is the fact that they all have a notochord, tail, and gills. All right, those are the big things that I'm looking for there for that answer that are also in your notes. All right, what does this show about their common ancestor? Well, if they all had these things, guess what their common ancestor probably also had? All right, here we have some limbs that are all one bone, two bones, blobbies, phalanges. So these limbs have similar function similar structure, but different function. And so are they homologous or analogous? And these are also terms that are found in your notes. Down here, same kind of thing, looking at the bird wing versus a butterfly wing. What's going on with these guys and what are they called? Then we have these fish, so you're going to look at the difference between the fish and think about how they might live. And you can always just Google cave fish if you're interested and see what's going on with them. Then you're going to answer a couple questions here about homologous, analogous, and vestigial. And what might these vestigial organs have been used for in our ancestors? All right, and this is the big one that I wanted to show you. Molecular evidence of evolution using cytochrome C, which is a protein found in our mitochondria. So looking at these proteins, we can kind of figure out which organisms are most closely related to humans. So we're going to be comparing all of these organisms to the human. And be careful, because I don't know why, but for some reason they flip-flop chicken and horse here at the top. So don't let that mess you up. So what you're going to do is you're going to take your highlight tool and you're going to compare everything to humans. So looking under 42, everything has a Q, so don't do anything. 43, everything has an A. But when we get to 44, some of these organisms have different amino acids, basically, than the human. And so what we're going to do is we're going to highlight any differences. So anyone that has something different than a P, this means stubborn, we're going to go ahead and highlight that difference. Anything that's not a P. Okay. There we go. And we're going to do the same thing here. So here's a Y. So anything that is not a Y, you're going to go ahead and highlight because we're highlighting all the differences. Anything that's not a Y. So when you get done highlighting, what you're going to do is look at chicken and then count across all the highlighted ones between the two categories, both here and here, and add them all up, okay? And then that's what you're going to put in your chart down here for chicken, the number of differences from humans. And so the idea is that if you're closely related, you're not going to have very many differences. And the further you are from each other, the more differences you're going to accumulate. And this little dash here, you do highlight that as a difference because it is not an E. So let me make that clear for you. That is a difference. All right, so highlight, count them up, and then you have a couple questions to answer. Hope that helps. Bye, guys.